Let's record to the cloud one more time and share our screen here. So let's write a note here. This code calculates the roots of second order polynomial and tells the user about the types of, or the type of roots. We actually learned, so the algorithm is clear. You want to read the ABC, you want to calculate the discriminant. Let me bring the whiteboard. You want to calculate the discriminant, tell the user a message, and eventually calculate the roots. In fact, there was one extra requirement. You also want to calculate the polynomial from -10 to 10. So that's an extra piece that you want to do a plotting inside this. And this shows you how plotting is quite useful. It always appears in any engineering application. So does anyone recall how we get started about getting an input from a user? Just unmute yourself if you recall this.
We can name the someone else speaking.
No, go ahead.
We can say, for example, A equal input, and then open brackets, and then what is it called? The single, as the double. Okay, sorry, the double.
A single or double, it doesn't matter. Actually, both of them work.
Okay, and then write, please enter the value of A.
Very good.
And then semicolon.
Great.
And then do the same for B and C.
Excellent. Let me do them quickly here. B, and here B, here C, and here C. Anything else you recommend? Yes.
Okay. Okay, I was going to say, we say, for example, now roots or discriminant D equal B squared minus 4AC, B squared minus 4 times A times C.
Do I need any dots here?
No, it doesn't matter. If you put them, there's no difference.
Very good. Very good. It doesn't really matter because these are scalars, so it's not gonna matter anyway. And now what should I do after calculating the discriminant?
If D less than 0, maybe I should let someone else try.
Very good. Excellent. Excellent. Thank you so much. Anyone would like to code us this part here? Just unmute yourself and we can work it out together. If anyone would like to code with us. Okay, so it's basically, as your colleague said, I just need to list the possibilities. The first one, if D equals 0, then basically, and first thing to note that MATLAB already made this in blue. It recognizes this as a programming construct, and then it indents. Do you see what's happening here? Like when I hit enter, the pointer here doesn't go to the first, the beginning of the line. It actually indents a little bit. This is good for readability purposes. It makes your code easier to read. In other programming languages, like in Python, for example, this is a must. You have to indent. It's not an option even. In MATLAB, it's up to you. Okay, so if D is greater than 0, I can display a message for the user. Remember our analysis here on the whiteboard. If D is greater than 0, I need to display a message here, and I can use, as we discussed with your colleague, either single quote or double quote. Here, 2 different real roots. And let me just develop this piece. I will develop just the F statement and then upgrade it a little bit to calculate the roots and, to do the plotting. But let's first get the basic chunk, which is telling the user what is the status of the root. And then else F D equals 0. And here I'm actually doing a mistake. And I will ask someone of you who might have some MATLAB experience In this case, I need to display the following message: 2 repeated roots. Someone might like to call this one single real root, 2 repeated real roots. But it's better to call it this way. It's repeated. It's made wise. Someone is telling me, yeah, exactly, Muhammad. It should be double equal, not an equal. And I have to clarify this. First of all, you see MATLAB is putting a red line here under the equal. By the way, it also put a red line under the if statement. That's because it's waiting for the end of this statement. Once we put the end, that will disappear. So this is not a big deal. But here, if else f d equals 0, MATLAB is unhappy because it wants me to put another equal sign next to it, another equal sign next to it. The reason for this is the following. If you assign a value to a variable, like you are saying x equal 5, then you put one equal sign. But if you are asking MATLAB, does d equal 0, then you have to put 2 equal signs. That's when you are asking the question, is it equal to 0 or not? Okay. So thank you for pointing this out. Now, the last piece is up to you. You can put it as else, and that's the only remaining possibility. So the d, it's either greater than 0 or equal 0 or less than 0. So else is the last possibility. Or if you want to be specific, not specific, explicit about it, you should say else f d is less than 0. Okay, so I'm going to leave it as else. Then the message here to the user, if it is else, the only remaining possibility is being less than 0, I'm going to say 2 complex roots. And I should close this. And I should end the if statement. Okay. When I put the end here, the red line under the if disappears right away. I'm going to put a comment here, and I will leave it for you. Another way to do it is to say else if d is less than 0. Both of them work. Both of them work nicely. Okay. That's the basic idea of the code, is the if statement and its branching. However, there are a couple of other requirements. The script should also report the values of the roots and also plot the polynomial from -10 to 10. Let's first go to reporting the value of the roots. It's not a big deal. It's right away. You calculate x1, and that's basically minus b plus or minus the square root of the discriminant over 2a. So I can actually do this calculation here, maybe x1. And I can write a comment here first, root x1 equals minus b plus square root of the discriminant. The whole thing is divided by 2a. That's why I'm putting 2 brackets. The whole thing is divided by 2a. And the other x2, the other root, I can copy this. Copy this expression here, and I can put a minus sign in this location. So these are the 2 roots. Now I can report them. Maybe you can report them at the end after you have displayed one of these messages. Remember, the user will only see one of these messages, will not see all of them, depending on which branch of the if statement has been satisfied. Then I can put a comment here reporting the roots. For example, I can say display the first root is an semicolon. I can display the variable x1. And similarly, I can do the same thing for the second root here. By the way, you can actually make the output in a nice formatted table, but we are not going to cover formatting of the output in this crash course. This is like to make things nice. How do they look? How do they look like for the user? Like you can make, you know, a line and headers, and you can really format your output in a very nice way. But we don't have to learn this. It's not a fundamental thing. It's just something to make your output look nicer. The second root is and I'm going to display x2. Let's actually test it before we do the plotting, because I need an input from you how we do the plotting. We need to test it first. Let's test it on some symbol, on two cases. Let's make two test cases. It's always a good idea to test your codes once you develop them. So let's create two symbol test cases. I know for a fact that x squared plus 1, for example, it has complex roots, right? So this one has the following complex roots, plus I and minus I. And as a matter of fact, I can also make another test case, but one has to be careful how to read the ABC from this, right? Remember the form of the polynomial. The other test case, let's say x minus 4 all squared equals 0. I need to expand this expression to give me x squared, let's say minus 8x, and then plus 16 equals 0. And I know for sure that the answer for this is 2 real repeated roots, basically 4 and 4. Let's do the two test cases. And I forgot what I recommended last time. Always good to start with clear all CLC at the beginning of your code. So let's run it. It's asking for the value of A. In the first case, the value of A is 1. Or you can recognize this. The value of B is 0 because there is no X term. And then the value of C is just 1. As you see, the first root is plus I and the second root is minus I as expected. These are complex roots. The other case, let's run it one more time. The value in the other case, the value of A is 1. The value of B is minus 8. The value of C is 16. And the first root is 4. So first of all, it told me that there are 2 repeated real roots, and the first root is 4, and the second root is 4. In fact, also in the previous case, but it has been cleared from the memory. Let's actually run again and reproduce it one more time. 1, 0, 1. Says that there are 2 complex roots. So it seems that the code is working fine. It remains to show how to do the plotting. So remember, the question is asking for one last requirement, is to plot the polynomial from minus 10 to 10. I could have made it more difficult, and I will leave it to you as an exercise to think about it. Now things start to become an art of how you display your data and stuff like that. I could have asked you, make a plot such that we can see the roots in the plot, okay? Or at least if we cannot see it, we at least see where the parabola gets as close, in the case of complex roots, where the parabola gets as close as possible from the x-axis. I will leave it to you as an exercise. This is not easy, how you can make something like this. We ask it for something simpler, just plot from minus 10 to 10.
We need to plot, and on the plot, on the x-axis, if it crosses the axes, we show where exactly it crosses. Is this the question?
Yes, basically, I'm asking even for a simpler version of it. Make your code, your plot, such that if there are real roots, we can see them on the screen. Like the range of the x can easily be seen on the screen. Because when I ask plot from minus 10 to 10, suppose that the roots are 21 and 22, right? Then they are not going to appear at all in the plotting. So I could make it a little bit tricky by asking you, please make sure that the range of the x is explicitly containing the roots. Okay? It's not tricky, I would say, it just needs extra effort. That's all what I'm saying. But here we are asking for a similar version, plot from minus 10 to 10. And we learned this. There is really nothing difficult here. So I can do the plotting part at the end. So plotting from minus 10 to 10. I haven't used the X variable so far. I've been using X1 and X2. So I'm allowed, I mean, I can use another variable called X. It's gonna run from -10 with a step of 0.1 to +10. And then did I use Y? Nope, I didn't use Y. So let me use Y equals A square A times X squared. And I probably need to have a dot here, and then plus b times x. By the way, I don't need a dot between the b and x because b is a scalar, it's just a single number, bx, and then plus c. So that's basically the x and y. And then plot x and y, you might need maybe to make it dash dash anything red. And we can put an x label. This is x, y label. This is f of x, and yeah, title maybe second order polynomial. Let's run one more time. It's asking for which example should we take? Maybe let's take this example, this x squared minus 8x. So the value of a is 1, the value of b is -8, the value of c is 16. Yeah, it does the plot. And we see that the parabola is barely touching the x-axis, as you see here in one point. I hope you can see this, the plot. Maybe I should reshare.
No, you don't.
Is it clear now?
Yes.
Very good, very good. So that's basically the plot that we generated. Do you guys have any question here on this basic plotting? Any comments or questions? Let's see the chat here. Okay, so if no comments, then you're gonna also stop the recording and do an exercise in the breakout rooms, and then come back here to the main room trying to do it together. It's an application on the F statement. So I'm gonna stop the recording. Well, actually, let's state the exercise first before we stop the recording. It's the exercise number 6 in this document. Again, it's the same link I posted before in the Google from the Google Drive. Let me actually take it one more time. Share, copy link, and copy the link to everyone here on the chat. So it's and I'm gonna share the screen as well. So it's problem number 6. It's basically you are asked to generate a MATLAB script that takes 2 values from the user. Okay, basically the so someone is gonna give you the radius r and the angle theta. So remember, there is the Cartesian coordinates and there are the polar coordinates, and you can convert from one to them. What we are claiming in this problem, it's easy to compute Cartesian coordinates if you are given r and theta. Okay, the reverse process is not simple. Okay, if someone is giving you x and y and you are asked to calculate r and theta, so r is easy, but theta is tricky. And let me the exercise is explaining why. R is easy because it's just the square root of x squared plus y squared. It's the radius, right? But theta, you really need to decide, is it in the first quarter or the second quarter or the third quarter, and so on and so forth. So it doesn't come as a simple 10 minus 1. And you will need actually to check online, and I will leave it to you in the breakout rooms to check online what is tan inverse. How do you calculate tan inverse using MATLAB? It's not difficult. Just Google it, what's tan inverse. The difficulty, because you have some cases here. If x is greater than 0, I'm not gonna discuss the mathematics of the problem, so that I will leave it to you to, because I'm pretty sure if you have some engineering background, you have seen this before. But what matters is the algorithmic development of a software. Basically, if x is less than 0 and y greater than 0, then the angle theta is not what you get from tan minus 1 right away. You need to add a pi to it, okay? You need to add a pi to it to ensure that it is in the second quadrant, okay? If x is greater than 0 and y is greater than 0, you need to subtract pi from it. Remember, the default angles in MATLAB are radians. They are not in degrees. So what you get is automatically in radians. So basically, you need to decide which case you have here. Depending on the case, you might need to do one of these, variations of the angle. So we are asking you to write a MATLAB function, not really a function. Let's change this into script. We haven't put function yet. Write a MATLAB script from the user x and y, and the corresponding r and theta, and your script should return the corresponding r and theta. Again, instead of the function, please change this into the script. The script has to return the value of the angle in both radians and degrees. And that's something you need to search online. How do you convert from radians to degrees in MATLAB? Or you can develop yourself if you remember the mathematical relationship between the two. You don't need a built-in function in MATLAB, okay? And you are asked to test your program in the following couple of cases just to make sure that your code is working well. All right, so I'm gonna stop the share. I'm gonna stop the recording.